All right, welcome back for page 3. Let's see how this thing goes. So we're going to start off with just a little story about the Pythagorean theorem. So one thing that's really, really important is earlier on in your math career, we didn't really stress simplifying those radicals, and that's just the small little piece that we're kind of making sure we discuss here. So when you see a problem like this, remember the Pythagorean theorem is that whole a squared plus b squared equals c squared, which is fine, but it's really just says take your two legs, whatever they are, see this 8 and this 10, square those two legs, add them together, and that should be the same as the length of your hypotenuse. But sometimes you're not lucky. This is one of those cases where you square the two legs and add them together, and that should be the square of the hypotenuse. See, these are very, very different stories. This one directly says to find C, I need to add these two results together, but this one is a little bit backwards. So we just got to be a little bit careful to make sure that we just take our time here, because 16 squared, of course, is 256. 10 squared of 100. Okay. And so if we were to subtract 100 from both sides, we get 156. So that would tell me that A is the square root of 156, which is okay, but that's really not a very good value. I want to see if I can simplify that a little bit because I want to do this as exact form. And see, what a lot of us have done historically is taken the square root of 156 and said that it's 12.48. But that's not really 12.48. That's about 12.48. I can't write a decimal that is exact because this decimal technically goes on forever and it never repeats. So what we're going to do is we're going to try to break down the number 156. And I'll be honest, I don't automatically see a nice, easy value that goes into 156, but I know it's clearly divisible by 2. And because 78 ends in 2, it's clearly divisible by 2 again. And of course, 39 is 3 times 13. And so now, if we are looking for those things that pair up, you'll notice that we have a pair of 2's. So instead of calling this 156, I'm going to call it a pair of 2's with a 3 and a 13 inside together, which is really 39. So we had our story right a little bit ago that said the square root of 156 was 12.48. But let's see, 2 times the square root of 39 hopefully is also 12.48. And that tells you that I did okay. And 39 is a much smaller number, a little easier to follow than 156. So that's our answer. Now, the second one, 8 squared is 64. 10 squared is 100. So we got 164. So I need to simplify the square root of 164. Now, just like before, I'm going to try to break that down as much as I can. And I did notice that 164 is divisible by 4. That's something that just jumped out at me. And you might have seen that the number 2 goes in, and that's okay as well. But what's cool is the number 41 is already prime, and a 4 is made up a couple of 2's. So my value C should be 2 square roots of 41. Now, I'd like you, especially when you're first getting used to taking square roots and doing that, let's just double check and see how we did. So I'm going to ask my calculator about the square root of 164. And I want to make sure that I have the same answer when I took 2 times the square root of 41, because I should have exactly the same answer. And I do, so it means I did okay. Now, over here, this is a problem that is going to immediately jump out at you and go, oh my goodness, we're going to get really, really large values. I'm going to take the two legs squared, add them together, get the hypotenuse squared. And I get it. We're going to do this and we're going to get a massive number. We get another really large number. This looks like troubling sets of values. I'm a little bit worried about it. But let's see, if I take 625 and I subtract 576, I got b squared is 49. Oh, that's actually kind of nice because when I go to take the square root of both sides, well, that's just 7. Now, when we talked about playing Go Fish, 49 is a couple of sevens, but there's nothing left in my hand. The square root of 49 is, in fact, 7. There's no root left. And I can write it perfectly because it was a perfect square. And we're done with that. Okay, moving on to number 9. Now, again, I'm going to go quickly. I'm not going to teach this topic. If you would like to know how to do this topic because you really, really struggle with this, there's a separate video where I went over the basics of this. I'm just going to go quickly through these because we have discussed this a lot. So again, please refer to the other video if you do not know how to do 45, 45, 90s or 30, 60, 90s. So that being stated, I'm going to go fairly quickly. We should know that in a 45, 45, 90, these answers are both the same. And this side right here is root 2 times the short side. Over here in a 30, 60, 90, the hypotenuse is twice as long as the short side, and the medium length side is root 3 times the short side. Over here, if you take your hypotenuse, you see hypotenuse was twice the short side, so the hypotenuse cut in half should be the short side. And just like before, this is 13 and 13 roots of 3. Here's 20 and 20 roots of 3. That fast. Now, here's where we start to get into the harder problems. So when you try to go from the short side to the hypotenuse of a 45, 45, 90, we multiply by root 2. So I'm going to need to divide by root 2, which is actually something we've discussed that we're not supposed to do. So if I do the little fixed step that we talk about, 9 roots of 2 is on top and 2 is in the bottom. And I know we always want to try to fix that, but I really can't do anything with it because 2 doesn't go evenly into 9, and I'm done. This is 9 roots of 2 over 2. I know that's an uncomfortable number for a lot of people, but it is what it is. Now, letter E, move this thing up so we can see a little bit better. But notice that 13 led to 13 roots of 3. So 7 roots of 3 should lead me to 7, because to go this way, I had multiplied by root 3. So to go backwards, I needed to divide by root 3, and I got 7, and therefore hypotenuse is twice as big, and that's 14. And obviously, same kind of story is happening here. If 7's here leads to a 7 roots of 2 here, then 6 roots of 2 here means both of these numbers had to be the number 6. And that's it. That was it. Like I said, if you still need more help on those, there's a separate video that goes very slowly and meticulously through those. All right, I'll see you later back in class. Bye-bye.